Alright, ladies and gentlemen, today we're going to talk about parallel and perpendicular lines. So first thing we need to review, because this is something you should have learned in Algebra 1, are the two equations of a line, so the two forms that we can write a line in. The first is slope-intercept form, which is y equals mx plus b. If the board will write y equals mx plus b. Remember that in this formula, m is the slope of the line, and b is the y-intercept, which is why we call it slope-intercept form, because you're using the slope and the intercept to write the form of the line. The other one is called point-slope form, and this is the formula for point-slope form, y minus y1 equals m times x minus x1. Alright, so that's the formula you're going to use for point-slope form. And in point-slope form, the m is the same as it is in slope-intercept form. M is the slope. Okay? And then the coordinates x1 and y1 are a specific point that is on the line. Okay, those are the coordinates of a point that the line is on. Alright, so those are the two main forms of the equations of a line. Alright, so first, what is the slope of both of these lines? So the line on the left, and we see that this is slope-intercept form right here. So again, the slope is the number that's in front of x, so we can see that the slope of the first line on the left is 4, and the slope of the line on the right is the number in front of x, is also 4. Okay, so both of them have the same slope, 4 and 4. This says, will these lines ever cross? Doesn't look like it, so we'll say no. And then the next question, what do we call lines that will never intersect? Well, of course, we call those parallel lines. We've already learned that. Alright, so therefore, what we can conclude by this is that parallel lines have the same slopes, because these two lines up here are parallel, and we saw that their slopes were both 4. So the slopes of parallel lines are always going to be the same. Okay, moving on. Now, what do we notice about the slopes of these two lines? Well, the slope of this line is -1/2, and the slope of the other line is 2, because they're written in slope-intercept form. So the observation, this is kind of hard to tell, but you notice that they both have a 2 in them, right? And on one, the 2 is on the bottom, right? -1/2, 2 is on the bottom. 2 is really, if you made it a fraction, it would be over 1. So what you really need to kind of notice right here is that you just flip the fraction, right? To go from 1/2 to 2 over 1. Okay, so we call that a reciprocal. Right? And also, we notice that they have different signs. One is negative, one is positive. The word we use for different signs is opposite. So they are opposite reciprocals of each other. Okay? Now, looking at these two lines, how do they look like they interact? They're not parallel. They cross to make a 90-degree angle right here. Well, what do we call lines that cross to form a 90-degree angle? We call them perpendicular lines. Alright, so we've got perpendicular lines. So what we conclude right here is that perpendicular lines will have opposite reciprocal slopes. Okay, their slopes are always going to be opposite signs, and they're also going to be reciprocals of each other, which means they're going to be flipped fractions. One would be like 1 over 2, the other's 2 over 1. Or one could be 2 over 3, and the other's 3 over 2. But then they're also opposite signs. So one's going to be positive, one's going to be negative. Okay, so let's practice opposite reciprocal real quick. What is the opposite reciprocal of -3? So first, let's make -3 a fraction. In order to make a whole number a fraction, you just put it over 1. So we've got -3, and that's going to be over 1. to make the opposite reciprocal, okay, reciprocal means we flip the numbers, okay, so we'll put 1 over 3 now and change the sign. So instead of a negative, we would make it positive. So the opposite reciprocal of negative 3 is just positive 1/3. Now, then what's the opposite reciprocal of 1/4? Well, let's just flip it. So we put 4 over 1, and we got to change the sign. So instead of being positive, we'll make this one negative. And of course, negative 4 over 1 is just 4. So the opposite reciprocal of 1/4 is negative 4. Okay, so looking at these graphs right here, you need to be able to tell by looking at a graph if the lines are parallel, perpendicular, or neither. As you can see, this first one, they're not parallel because they cross, and they're not perpendicular because they don't cross to make a 90-degree angle. So this one would be neither. The second one, they look like they're crossing to form a perfect 90-degree angle, so we would call those perpendicular. And usually we don't base stuff off how it looks, but you haven't learned yet how to do it, how to figure out, mathematically that they are definitely perpendicular. So we're just eyeballing it right here. And then the next one, they look like they're parallel because they look like they're never going to touch. Of course, one could be off a little bit, but just to kind of get an idea of what the graph should look like, if it's parallel, perpendicular, neither, those are your examples there. The board will wake up. We'll move on to the next slide. Okay, so looking at these. Okay, so looking at these functions, we need to determine if the functions are parallel, perpendicular, or neither. So we got to look at their slopes. Remember, parallel means they have the same slope. Perpendicular means they have opposite reciprocal slopes. And neither would be a situation where they're neither parallel nor perpendicular. So right here on this first one, we see the slopes are both 2, right? The number in front of x are the slopes. So since they're the same, those are going to be parallel lines. All right, let's look at the top right one. We see one slope. There's an x missing right here, by the way. It should be an x right there. So one slope is negative 1/3. The other slope is 3. Well, those are opposite reciprocals because if you take negative 1/3 and flip the fraction, make it 3 over 1, and change the sign, that gives us 3. So those are opposite reciprocals, which means that those two lines are perpendicular. All right, the bottom left one, these two slopes, they're not the same like the first one, and they're not really opposite reciprocals either. They're just opposites. All we did was change the sign. We didn't flip the fraction too. So this one's neither. They've got to do both. You've got to change the sign and you've got to make it a reciprocal. All right, and the last one, the slopes are 3 and 3. Those are the same, so that one's like the first one. It's parallel also. Okay, and a lot of this stuff should be a review from Algebra 1. All right, so now what we're going to do is actually take points and determine, are these points going to give us lines that are parallel, perpendicular, neither? So what you've got to do is find the slope. So we need to find the slope of line A. Slope, to find it with 2 points, you've got to take the y coordinates and subtract them and subtract the x coordinates. So we use this formula right here to figure out the slope. Something, again, you should have learned in Algebra 1. Okay, so we take y2. We can label these points with x's and y's. We can call the first point 1's and the second point the 2's. So y2 minus y1, 9 minus y1 is negative 1, so we put a minus 1 in there. And then x2, which is 4, subtract, sorry, that should be a 1 right here. x2 minus x1, which is 0. So we get 9 minus a minus. Minus a minus is really adding a positive. So that's 10 over 4 minus 0 is 4. But you got to reduce your fraction. So 10 over 4 is 5 over 2. Now let's do line B, same formula. So we got x and y, x and y. All right, so let's say we got y2 is 1 minus y1, 3. x2 is 4 minus x1 is 0. 1 minus 3 is negative 2. 4 minus 0 is 4. Right, so that's going to reduce to give me negative 1/2. All right? So looking at these two slopes, are they the same or are they opposite reciprocals of each other? All right? So this one gave me 5/2, and this one gave me negative 1/2. Well, they're opposites, but they're not really reciprocals, because 5/2, the opposite reciprocal of that would be 2/5 with a negative. So they're not opposite reciprocals, and they're obviously not the same. So this would be neither. Those points would give me neither parallel nor perpendicular lines. So I'm going to give this a pause the video and let you guys go ahead and pause yours. Give the next one a try by yourself. Okay, so when you find the slope of line A, you should get 1/3 for the slope. Right there's the work. The slope of line B is negative 1/3. On these, make sure that you use all the minuses. You can count your minuses and your points, and there should always be 2 more minuses than what your points give you. So like right here, we got a minus on the 4, and we've got a minus on the 1. So that's 2 minuses, but we should always have 2 more than whatever the points have. So that's 2 of them. You should have 2 more minuses in your formula. Down here you can see we've got 1 minus, 2 minus, and then these 2 minuses right here that we turn into a plus a positive. So count your minuses. You should always have 2 more than the minuses that are in your points. Just make sure you don't leave those off. So when we solve the slope for that, we get negative 1/3. So looking at these, 1/3 and negative 1/3. They're not the same. One's positive, one's negative, and they're not reciprocals. And they're opposites, but they're not reciprocals. So since it's not opposite reciprocal, it's not perpendicular. Since they're not the same, it's not parallel. So this one is also neither. Okay, now we're actually going to take a line and find the line it's parallel to it. So this says write the slope-intercept form of a line that's parallel to y equals 2x minus 3 that goes through the point 25. So what do we know about it? If it's parallel to this, we know that it should have the same slope, right? So the slope of this is 2. So we know the new line we're using should have a slope of 2, and it tells us it's got to go through the point 25. So this is where we're going to use the function y minus y1 equals m times x minus x1. We're going to use that formula to find the form of the line. So we're going to take the point that we are using and the slope and plug them into point slope form. So y, I'm going to write y minus, y1 is the y coordinate of my point. x1 is 2, y1 is 5. So I'm going to plug 5 in for y1 equals, and now I've got m in my function, that's 2, times x minus the x coordinate. x1 was 2 in my point. All right, now all we got to do is distribute. 2 times x is 2x. 2 times minus 2 is minus 4. And then just add 5. And that will put our function in slope-intercept form. So I get y by itself on the left, that's the whole idea. And on the right, notice I add the 5 to minus 4, right? Because those are like terms. Minus 4 plus 5 is plus 1. So here's the answer. This is the function of a line that is parallel to 2x minus 3, but will go through the point 25. It'll go through that point. So I'm going to pause it. You guys see if you can try to do that same process on the next problem. Okay, so you can see right here that we want to be parallel to the line y equals negative 3x plus 1. So we've got to have the same slope as that line if we're going to be parallel. So we've got to use the slope negative 3, so it's the same as that line. And we're also going to use the point 1,4 because we want to go through that point. So we take that slope, negative 3, and the point 1,4 and plug them into point slope form. Once we do that, we got to distribute the negative 3. So negative 3 times x, negative 3x. Make sure when you do negative 3 times negative 1, you get positive 3, not negative 3. Negative times negative is positive. Then add 4 to get y by itself. So our answer is y equals negative 3x plus 7. That's the line that will be parallel, but we'll go through the point 1,4. All right, so the last thing we've got to do is what you probably anticipate. We've got to do the same thing, but make sure that they're perpendicular to the line. Okay, so if I want it to be perpendicular to this line, okay, I don't want it to have the slope of 2. Remember, perpendicular lines got to have opposite reciprocal slopes. So that's the only real difference on these problems is you're going to not plug in the same slope, you're going to use the opposite reciprocal. So we've got to figure out what's the opposite reciprocal of 2. Well, 2 is a fraction over 1, so when we flip it, we get 1 over 2, and of course we got to change the sign. It's got to be the opposite and the reciprocal. You got to change both things. So we're going to use our slope of negative 1/2. All right, we flip it and change the sign. So that's the slope we're going to use, and we're going to use the point 43. 4 is our x1, and 3 is our y1. So use the same formula, y minus y1, so y minus 3 equals m. M is now negative 1/2, right? We're not using 2 this time. We're using the opposite reciprocal, times x minus the x coordinate, which is 4. Distribute. Everything else is exactly the same as when it was parallel. Negative times negative is positive. When you do 1/2 times 4, right, easy way to think of it is do 4 times the numerator. 4 times 1 is 4, and then divide by 2. So 4 divided by 2 is 2. And then to get to y by itself, we just need to add 3. So we get y equals negative 1/2 x plus 5. That's the line that will be perpendicular to y equals 2x minus 3, but we'll go through the point 43. All right, I'm going to pause the video. You guys pause it and give this last problem a try, and we'll go over it. Problem, you've got a slope of 2/3, but we got to be perpendicular to that. So we're going to do the opposite reciprocal for our slope. So we're going to flip it, make it 3/2, and change the sign, make it negative 3/2. So the slope we're going to use is negative 3/2, and go through the point negative 2, 6. So x1 is negative 2, and y1 is 6. Plug those into point slope form, just like we've been doing, and then you're going to distribute. Now make sure right here when you plug in, when you do x minus negative 2, again you're minusing a negative, so it makes it add a positive. Essentially, when you plug in your x1 and y1, the signs just change. If you go back and look at the other problems, you'll notice negative 2 was x. When we plug it in, now it's positive 2. But y1 was 6. When we plug it in, now it says minus 6. So those signs are just going to be the opposite of what they were in the point. All right, so now you keep distributing, and then you're going to add 6. And when you add 6, you get y equals negative 3/2 x plus 3. That's the line perpendicular to y equals 2/3 x minus 1, and goes through the point negative 2, 6. All right, let me know if you guys have any questions. If not, it's time to practice.